Hello everyone. Today in this video, I will tell you how to find out derivative of a function using first principle. What is the definition and formula for it? Let y equals fx be a function and we want to find out its derivative using first principle. So y equal fx is a function. Its first derivative, what is its first derivative? The rate of change of y with respect to x, which is defined by this. We denote it by f dash x, which is equal to dy over dx, equals limit h tends to 0, fx plus h minus fx upon h. So by computing this, by computing this limit, we can find out the derivative of a function, and which is known as differentiation from first principle. What are the steps for finding derivative? With the help of the example, I will explain you what are the various steps. First step is, first of all, we will write down the formula which we have discussed over here. This is the formula to find out derivative of a function using first principle. The first step is write down the formula. Limit h tends to 0, fx plus h minus fx upon h. First of all, we have to write down this formula. Second step, we will find out fx plus h. What we will do? We will find its value. We know this. We will substitute the values and we will simplify it. fx is sine x. So fx plus h, x is replaced by x plus h. So here also in RHS, x will be replaced by x plus h. So fx plus h is sine x plus h. Substitute the value of fx and fx plus h over here. In the third step, what is the third step? We will substitute the value. So f dash x equals limit h tends to 0, fx plus h, that is sine x plus h, minus fx, that is sine x upon h. Now substitute the value, equals limit h tends to 0. Now we will simplify it using the formula sine c minus sine d. This is d and this is c, because we know that sine c minus sine d equals 2 cos c plus dy2 into sine c minus dy2. Using this formula, 2 cos c, that is x plus h, plus d, c plus d upon 2 into sine c minus d upon 2 whole divided by h. Now simplifying it, limit h tends to 0, 2 cos 2x upon 2 plus 2x upon 2 will become x plus h upon 2. We can write like this, into limit h tends to 0 by the algebra of limit, sine, this will cancel out, sine h upon 2 and this is h. What we can do? We can divide it by 2 and multiply it by 2 for make it a formula. And if h tends to 0, h by 2 tends to 0. Why we have done this? Because we know that if theta tends to 0, sine theta upon theta is 1. But for that, what should be the condition? This, and this should be same. These theta should be same. So we have done this over here. So now substituting the value of limit, it will become 2 cos x plus 0, that is simply x, into this whole will become 1 into 1 upon 2. This 2 is there. Cancelling this, you will simply get cos x. What is the final answer? Derivative of sin x is cos x, where fx is sin x. These are the steps and method. Let's take one more example. Find the derivative of fx equals cos x using first principle. What is the first step? We will write down the formula. F dash x equals limit h tends to 0 f x plus h minus fx upon h. Now substitute the value of fx plus h and fx. We know fx is cos x, fx plus h, that is cos x plus h, replacing x by x plus h both sides. It will become cos x plus h minus cos x upon h. Now using the formula of cos c minus cos d, we know that cos c minus cos d equals minus 2 sine c plus d by 2 into sine c minus d by 2 using this formula. C is x plus h and d is x over a, minus 2 sine c plus d upon 2 into sine c minus d upon 2 whole divided by h equals limit h tends to 0 minus 2 sine 2x upon 2, that is x, plus h upon 2 into sine, this will cancel out, sine h by 2, and this h is there, and limit h tends to 0. This h is there, and we know that limit theta tends to 0, sine theta upon theta is 1. But for that, what is the condition? The 3 theta should be same. So what we will do? We will, it is h, we can divide it by 2, we can multiply by 2. And if limit h tends to 0 implies h by 2 tends to 0. Now substituting the limit, we will get minus 2 sine x plus 0, that is simply sine x, and this will become 1, and 1 upon 2, this 2 is here, it will cancel out. Its answer will be minus 2 minus sine x. So f dash x is minus sine x, where fx is cos x. So derivative of cos x is minus sine x using first principle. These are the steps which we have discussed. That's all in this video. Thank you for watching.